We'll see if this works. Okay, go ahead.
Oh, cool. There's a red button that says recording in the top left-hand corner. Interesting. Anyway, I did all this CAPA except for number 3.
Number 3,
And
let's see. For the previous problem, the one where we're looking at HR diagram and the evolution of a low mass star, indicate which locations in the HR diagram correspond to places where the evolution is slow. Answer should be in the order they occur in the star. Right. Hint, there are exactly 3 of them. That's a good hint.
yeah, the hint was, it indicated it was probably a dwarf star and it was a main sequence star, but
right. So white dwarf and main sequence. So main sequence, certainly, that's where a star will spend most of its normal life. The white dwarf is also an extraordinarily long-lived sequence. So in mine, it's G and D. What is the next? So those are the 2 of them. That's right. What's the third one?
I mean, I figured it's not the planetary. Oh, sorry. I'm just like,
No,
sorry,
no,
go
it's
on.
good. It was not a rhetorical question. I don't want to just give you the answer. I want to talk.
Okay, yeah. So I figured it's not a planetary nebula because
That happens pretty fast.
like yeah, it does. It all happens
It's over
really
in
fast.
100 years or something. Yeah, a couple 100 years. Yep, agreed.
And then I also figured it's not C, which is the helium, the double burning helium core, I think it's called. Sorry.
Yep.
The red giant with helium burning shell. Yeah.
Red giant with helium burning shell, right? So that is on its way up the red giant branch.
Yeah.
No, that's a hydrogen burning shell. I'm sorry. Helium burning shell would be somewhere in here. Right. So for a low mass star, there's basically 2 main sequences where a star is burning something steadily in its core. And in those phases, not much is happening to the star. In all the other phases, dynamic things are happening. Either you have some central helium ash or carbon ash that is getting more massive and slowly shrinking and slowly making all the other star parts do different things. But in the main sequence, when you're burning hydrogen and helium, that is a very slow-lived, nothing much is happening phase. And the other one is the helium main sequence, where you're just burning helium in the core. It doesn't last nearly as long as the hydrogen burning main sequence, but it's completely analogous to the hydrogen burning main sequence. Not much is happening. You have a stable nuclear fusion happening in the core, and that's a stable part of all the rest of the star's life too.
So would the answer be, for this case, be I? Because
I'm not seeing your particular letters.
oh no, I'm looking at yours.
No, mine, right? So for mine, no, I would be, for me, the helium flash, red giant helium flash.
Oh.
And then it comes back down, and the helium main sequence is probably, for me, F. But right, you've already gotten 2 right, so you know which is which, right?
Yeah.
Okay. So this is going to
just be helium burning, correct? Because that does itself last relatively long.
Helium fusion in the core.
Yeah. Okay. Mm-hmm. Sorry. Thank you.
You're welcome. Did you get it? You haven't tried
hold
it yet.
on.
Do you want to see this round picture of the day? I'm itching to show somebody this.
Sure.
Okay. They're pretty good. Let me know when you're ready.
Wait, can you hear me?
Yes.
Okay, sorry. I thought I was just like, did my sound blow or something? But yeah, I got it. Thank you.
Oh, good. You're welcome. Okay, starting picture of the day. Check this out. This is a cluster we've been looking at a lot in class, the Pleiades, a fairly young cluster, 100 million years old. You can see all the bright blue stars still there. This is naked eye visible. You can see like 5 of 6 of these stars, maybe 7 of these stars. At night, tonight, if it's clear, you can go out and see this thing. This astronomy picture today shows the path of Venus over the next few days. Today's April 2nd and April 3rd. Tomorrow night, it's going to be right in the middle of the Pleiades. Venus is the brightest thing in the sky now other than the moon at night. So you can't really miss it. And if you go out tonight or tomorrow or the night after that, it's going to be basically right in the Pleiades. So go check it out. Yesterday's astronomy picture of the day. They're also excellent. There we go. Why isn't this working? Uh-oh. Oh, there it is. Asteroid or potato?
I mean, I'm assuming it's an asteroid because it's a striking picture of the
Well,
day.
it says looks a lot like the comet that they looked at, but this is in fact the April Fool's edition of Astronomy Picture of the Day, and it's actually a potato. But it's cool because they New Horizons flew by some outer solar system object, and they were surprised to learn that it looked a lot like this, like it had 2 lobes that were just sort of connected together. So this is not a crazy thing to think about astronomical shapes being. Let's see if we can find a picture of the asteroid itself. Yeah, this is the picture of the asteroid itself. That's an asteroid,
Oh.
right? That is a potato, but they look like
I mean,
those tricky APODers. You just never know what they're going to do.
that makes me upset.
That it was actually a potato. Yeah,
It's just a potato, like.
it's a potato, but it. Yeah.
So also, there's colloquium today, right?
There is colloquium today. Yeah, you should get an email about that from Dr. Marcus at some point today.
Yeah, no, I got it last night at like midnight.
Oh, did he send out something last night?
Yeah, he
Yeah, I'm
did.
behind on my email. Oh, look at that. Cool.
Yeah,
Hey, physics colloquium is back.
I know. I'm excited.
Yeah, me too. Hopefully
I
we'll
mean,
have a good attendance.
also like Scott is also like doing like a geology social tomorrow, which I'm really excited.
Okay, that's fun.
I know.
We're all craving human contact at this point, so anything we can
Yeah,
do.
yeah.
All right, I'm gonna stop recording because I think we're
Oh yeah, sorry.
okay.